What I'm going to do in this talk is I'm going to present a piece of research that I've been working on for some time with my colleagues in the School of Psychology, which is where I'm working. My colleagues are Megan, Lyon, and Nikki. And what we've been doing basically is on the psychology course, turns out that we need to teach research methods and statistics. Turns out that this is not students' favorite part of the psychology course. It turns out that one way that statistics is often taught is with a calculation activity. You give students some data set, could be from Microsoft Excel, could be on paper, you get them to do the calculations themselves. What I wanted to do was I wanted to see if we could create such an activity which would, in order to help students with the two main problems in learning statistics, which is statistics anxiety and difficulty understanding it. So the whole talk is about whether this activity that I've made actually works. So first of all, in terms of the psychology course, I'm teaching primarily the conversion MSc psychology, that's the masters, but for both the masters and the undergraduate programs, students need to learn statistics. So what you can see there is a summary of the BPS benchmark statement, various research skills and methods. So what that means is that students on the psychology course, in order for the course to be accredited, students need to learn statistics on the course. And obviously, across various scientific subjects, economics and engineering and medicine, students also need to learn statistics. The problem is that, first of all, students don't particularly enjoy statistics, tend to have a negative opinion of it, tend not to have much motivation. And the difficulty which students have with statistics is actually seen just from the titles of statistics books. Here's some examples. Statistics without tears is another. And so we can see, just in the way it's marketed, that students don't particularly enjoy this. There are two reasons why students have a difficulty with statistics, one of which is that it's difficult stuff. It's hard to understand. It turns out that across all ages, people have difficulty even with more basic statistical ideas like the spread of the data, the spread from the average sampling distributions and so on. And the hard thing is, they need to understand those in order to understand harder ideas like regression and analysis of variance. So you have to learn all the hard stuff first. That's one of the problems. And because it's hard to teach those big ideas, one of the common recommendations from the statistics education literature is to focus on those big ideas, variance and spread. Are all the averages the same? Focus on the big ideas rather than just rote memorization. One reason why statistics is difficult is because it is abstract. What do I mean by abstract? Abstract is something that doesn't physically exist. You can't poke it with a stick. The more concrete something is, the more closer it is to tangibly, physically existing, the easier it is to understand. What I'm doing here is I'm giving an example from the statistics educator Robert Delmas, talking about how statistics is abstract. So first of all, we have a whole bunch of people. You have a whole bunch of people. That's concrete. They're real people. You abstract that into some numbers. Now, every single person is associated with a bunch of scores. And then what you can do is you can abstract that even further into some descriptive statistics, means and standard deviation. You can abstract that even further into the shape, which is the distribution. And if you're looking at that shape and you have no idea what it means, that's kind of the point. And then if you want to use that data to infer, to find if a particular claim is true or false, that's an even higher level of abstraction. So no wonder it's hard. Another thing that's hard is the fact that it is based on counterintuitive logic. So when you're reasoning day to day, you're not using formal mathematical logic. People have a tendency to have difficulty reasoning with negatives. You know, if you get accused of robbing a bank, you get interrogated by the police, you get flustered. They say, did you rob the bank? You get flustered. You say, I didn't rob no bank. That's a double negative. Now you go to jail. Exactly, right? So people have difficulty dealing with negatives and also reasoning from an effect, a consequence, backwards to a cause. The reason I mention that is what I'm going to show you now is the logic of statistical inference, the logic of using statistics to prove if a claim is true or false. If there is no effect in the population is true, then p-value is high. P-value is high is false, therefore there is no effect in the population is false. This is a quadruple negative, and it also goes from the effect, P-value, to the cause, the truth about the population. So no wonder it's hard to understand. Another problem, and this is no surprise, is that given it's so difficult, students find it quite anxiety-provoking. Statistics anxiety, which is defined as a sense of worry, tension, apprehension due to exposure to statistics, affecting up to 4 out of 5% of graduate students who already have their degree, leads to lower engagement. Procrastination leads to lower engagement with the course and lower grades. And this is especially the case to do with mathematics when you're doing equations and calculations. And statistics anxiety is more prevalent. Students are at higher risk of it when they're in online courses and in faster courses like conversion courses. I mention that because those are the students that I teach who are therefore at a particularly high risk of statistics anxiety. So how do you teach statistics? One way to teach statistics is by use of statistical software. You can code in R or Python, or you could have software like SPSS. What I'm showing you here is a summary of different academic articles which are looking at the proportion of introductory statistics courses in psychology which are using some statistical software. And we can see it's kind of rising over time. The biggest review of this that I could find was a review from a Canadian university which looked at across 65 universities, over 250 courses. And what they did for each of those courses is this Davidson paper wanted to find out what kind of software do you use to teach introductory statistics. And what they found is about 4 out of 5 of them used some kind of software. So it's going up to about 4 out of 5. The most common type of software used is SPSS, which is being used by, 57, 58% of courses. Second most common was R, that's a kind of computing language. Third most common, we don't use any. The third most common software is none. So how do you actually teach statistics? One way that you teach is with manual calculations. You get someone to have some data from Excel or a printed piece of paper, and you ask students to step by step do the sums on a calculator. So most common, SPSS. Second most common, R, coding. Third most common, just use your calculator. Problem is it's never actually used in research. So the question is, does it have added value? It only has added value. It's only worth doing these kind of activities if they actually improve students' understanding and reduce their anxiety. There's no use having these activities, which they're very common, if they don't actually help students to solve those two problems in learning statistics. Problem is there's not much research on that. And there's a few theoretical reasons for thinking why it might or might not work. Maybe it improves understanding because you see where the numbers come from. Maybe not, because that's rote memorization. Takes a lot of time that you could spend on other teaching activities. Might make you more anxious because now you're exposed to all the equations. Maybe it makes you feel less anxious because, well done, now you have this successful experience. This doesn't tell us much one way or the other. What about the evidence? Well, we have some observational and experimental studies, and they're telling us different things. What they're basically saying is that some results, I'm not going to read them all off here, but some results say that different software makes a difference to how students learn. Sometimes it doesn't. So the evidence is very mixed here. Two big problems with this evidence: tend not to have a control group. So maybe the students who did well on that software were the students who were going to do well anyway. And also they tend not to measure anxiety or understanding. They use exam grades, or they use new novel items which aren't validated measures. And so there's not much evidence on this. Now, I work on the online conversion masters in psychology. And one of the activities we had, which we had inherited, let's say, from the in-person course, was one of these calculation activities. And because of the way the course is structured, it needs to be closely aligned with the on-campus version. So we had to do this activity. We were going to give this activity to the students, but I figured while we were going to do it, I might as well try to create an activity in such a way that addresses those two problems, anxiety and understanding. So I created a Xerti activity, which is a hand calculation activity. it was one of the, we called it a worked activity. That's kind of like an online version of a seminar for the online research methods and analysis module. So that's part of the online conversion masters in psychology. That's the first statistics class they have, by the way, and it was designed to improve understanding and reduce anxiety. So how it worked, it was a set of, show of hands, who here has used Xerti before? Oh, that's great, that's great. You know what Xerti is. So it goes through different steps. And it has videos throughout. So the first video was me saying, this is the big idea of this statistical technique. The statistical technique was called ANOVA. Show of hands, anyone know what ANOVA is? Okay, basically you have a whole bunch of groups, and ANOVA tells you if all the groups have near enough the same average. That's basically what it's doing, but there's a lot of math behind it. So what I would do, what the toolkit did is you had a video, then a few slides of performing some calculations step by step, then another video. So it was chunked section by section. And then at the end, it said, well done. Look at this big equation you've just solved. It was chunked across slides. I'd also had videos of the staff because that's teacher presence that reduces anxiety. What I wanted to find out was whether this calculation activity in particular affected understanding and affected anxiety, basically whether it helps. This is the method behind it. So what we did is we had focus groups of students. Now, those are the students who were eligible. So far, the only participants we've had are actually from the online conversion class, the people who've done the activity itself. If we've got students from other cohorts, we get them to look at the activity ahead of time. We have focus groups because then it allows participants to articulate their thoughts by talking to each other. And then we advertise this to the students on Moodle and also Microsoft Teams channels. And then we transcribed it Jeffersonianly. We used reflexive thematic analysis. I don't know if you can tell, but I'm primarily a quantitative researcher. Nikki did most of the qualitative stuff, so unfortunately, I don't think I can help you with the technical qualitative questions. So this is the results we had. So the study is currently ongoing. Right now, I'm in the middle of transcribing the data as we go. But in terms of the data that we've analyzed so far, we collected data from 2 focus groups, which was just 2 students each. So we've got 4 students so far, some of which are actually named after statisticians. So these are their pseudo names, their fake names. Ada, that's from Ada Lovelace. She invented coding. So we've got 4 participants here, and these are the results. So when we performed the thematic analysis, we found 3 main themes. Theme number 1, emotions and conceptual understanding in statistics. This had 2 sub-themes. What this theme did is this told us about the problems that students faced in learning statistics: negative emotion and difficulty understanding. So what this is doing is this is confirming what the previous literature is telling us about the problems that students face. It was the module I was worried about: panic, sheer panic. I was terrified of it. And difficulty understanding, I'm using a different part of my brain. I look at a formula and I freeze. So these are the 2 problems that students tend to face. The second theme that we found was about effective teaching, which is that students actually thought the activity and the module itself was structured rather well, passionate, got positive reinforcement. One thing that the students told us that they really liked was that when they went through the activity, they got the right answer. It said, well done. They get a green tick, which might not mean much to us if we're used to it. But if it's a subject which makes you feel very anxious, then that's a lot of good reinforcement. And breaking it down step by step made it more accessible. The third and final theme, which is most relevant to our research question, is about whether or not the activity actually helped. It did. So, first of all, we had some very nice general comments. It's helpful, it's good practice. I wish we could have more of these. One thing that the students consistently told us is they liked the videos were fun. The calculation itself, very boring. But exactly. But one thing they said is, in retrospect, I'm glad that I did it. They told us if you had told me to do it in advance, I wasn't looking forward to it, but it was actually worthwhile at the end. It had some added value. It did improve understanding. They understand the concepts, they better understand the equations, where all these numbers are coming from. It makes it concrete, and it also improves confidence. One of the main benefits of the activity is that it gave students an experience of successful problem solving. This is a subject which they have difficulty understanding. This is a subject which you have difficulty understanding, which makes you feel anxious. And now what we've done is we've catered an activity which scaffolds you upwards. And then we say, look at this giant equation with the sigmas and the f's and all the n minus ones, this big equation, and you finally solved it. You're actually a lot better at this statistics stuff than you thought you were. So you get a sense of accomplishment. It makes it less daunting. It improves your confidence. So that is a summary of the results. In terms of the discussion, it confirmed what we already knew. So that confirmed that the two problems students face is anxiety and difficulty understanding. It did improve understanding of terminology and equations. Now, it is the case that rote memorization doesn't equal understanding. However, this activity nevertheless was able to improve understanding. And it's good to include these visuals step by step. It also reduced statistics anxiety with a sense of accomplishment and confidence. The person you see in there is a psychologist. That is the psychologist Bandura. What Bandura was doing is he was studying fear and anxiety in relation to a belief called self-efficacy. Self-efficacy is the belief in your ability to organize and then carry out solutions to solve problems. Your ability to solve problems, which helps to reduce anxiety, because you could kind of imagine anxiety as the feeling that you're not equal to the pressure of the environment. Well, how do you get self-efficacy? Well, you get it through successful experience of problem solving. That's called a mastery experience, and that's what we just gave to the students. And so I'd recommend having this activity or activities similar to this at the beginning of the course. They said that students told us that not only did it reduce anxiety, it increased motivation because it gave them a great sense of accomplishment. Now, at this part of the presentation, normally what you see is click, 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 a lot of different references. If you want to see the references, you can go on that QR code there. And what I'm going to finish by talking about is that's the contact information if you want to contact me or you want to see this activity. As well as that, I also do other projects regarding to statistics education. I have some YouTube videos up there. There's the link there if you want to see my videos about statistics education. And as well as that, and I talked about this last time, my talk yesterday, is I've also worked with Megan Barnard in the School of Psychology. Megan, by the way, is another one of the collaborators on this project. And we developed a teaching resource called Statistics Launchpad. That's an online teaching resource helping students to learn and revise statistics. Does not assume background knowledge except for the ability to add. It goes all the way from mean to multiple regression. And so in summation, the good news is that this activity was able to address the two main problems that students had with statistics, and I would recommend the use of these type of activities. Thank you.